Hi everybody, the purpose of this video is to go over section 2 of chapter 2, and the topic for the day is circles. We are going to present two forms for the equation of a circle. One is the circle radius form. The other one is the general form, which is probably the least intuitive of the two. And then finally we will go over one application which will serve you well in your homework. Okay, so what is a circle? Well, you know, we've seen circles before, we know what they are, but what is a good mathematical definition of a circle? Well, a circle is a collection of points on a plane that lie the exact same distance from a given point. It has a center, there it is, and it has a distance which we will call the radius, and every single point, which is the exact same distance, i.e. this radius distance from the center, is a point on the circle. So to define it, well, we just did that. You got to define a center, there it is, and then you have to define a radius. Once you have found the radius, either directly or through the perimeter, the area, or the diameter, you know everything that you need to define the circle. And you can define it using the center radius form of the equation of a circle. And it is the most intuitive form, and this is how it works. Suppose that we have a circle which is centered at the point h comma k, where h is the x coordinate of the center and k is the y coordinate, and it has a radius r. Then this is the equation of the circle. Notice that it is a perfect square in terms of the x variable, plus another perfect square in terms of the y variable, and that was going to be equal to the square of the radius. So if you have a circle which has a center at 0, 0 and a radius r, then the equation for that circle is going to be x minus 0 squared, or x squared, plus y minus 0 squared, or y squared, and that will be equal to r squared. And if suppose that r is equal to 1, well then you have the notorious or famous unit circle, which is something you will learn much about if you ever decide to take pre-calculus. Okay, so our first example is to draw some equations for a circle in center radius form. And here we have a circle that is centered at -3, 4 and has a radius of 6. So the equation of this circle is going to have the following. It is going to be x minus a -3, which is just like x plus 3, the entire thing squared, plus y minus 4, the entire thing squared, and that will be equal to 6 squared, or 36. There you go. That's all there is to it. Okay, now here we have a circle centered at 0. So h is 0 and y is 0. So this will have the equation x minus 0, or just x squared, plus y squared, and that will be equal to the square of the radius, which in this case is 9. And you will also be asked to graph a circle with this particular equation. Now here, notice we have the circle that we have here is the quantity x plus 3 squared plus the quantity y minus 4 squared, which is equal to 36. So the center is going to be at -3, 4, and the radius is going to be the square root of 36, or 6. So the way we would plot this is you would plot the center, and then you would go 6 units away from the center, and that would be here, 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 and here. And if you plot that circle, then this is what you would get. Now, you do not have to draw circles like this. However, you do need to plot these in MML, and let's see how we can actually do that. So over here I have MML running, and here is the equation that I want to plot. So the way that we are going to do this, once again I'm going to be plotting this equation, is you can come over here and make the graph as large as you want to make it. You can either do that, or you can click on this to make it large, but I prefer to do it this way because I can make it as large as I want, where this only zooms to one side. Now once we do this, we want to click on the circle tool, which is this tool here. Once we've done that, we are going to want to click on the center. That will be at the point -3, 4. So -3, 1, 2, 3, up 4, 1, 2, 3, 4, and we'll just click there. That's our center. Now we want to To create this circle, we want to go out the distance of the radius, either up and down, up or down, or left or right, not diagonally. So I'm going to go to the right 6 units. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And there is my circle of radius 6. And then I can go ahead and check my answer. Now, if I did, I would not, it would be marked wrong because they want me to plot the circle associated with this equation. Now, as far as this equation is concerned, notice that I have a center which is at 1, 0, and the radius is 6. So let's go ahead and take a look at that. So once again, we have x minus 1, so the center is at 1, and y minus 0, so the y-coordinate is 0. So we want to click on a circle tool, and we want to find 1, 0, which is right there. Now notice that this is 36, so that means our radius is the square root of that, or 6. So I want to go 6 units, either up, down, or up, down, or side to side. So I'm going to go up 6. I'm going to go 6 up 6 times. That's 1, 2, 3, 4, 5, 6. I can check my answer, and as you can see, it worked out just fine. We now want to look at the general form of the equation, the circle. Now, how do you get that? Well, let's come back over here and look at this. We have x squared plus 3 plus y, x plus 3 squared plus y minus 4 squared is equal to 36. Well, the first thing we want to do is expand this. And if we do, we will have x squared plus 6x plus 9, and then expanding this, we will have y squared minus 8y plus 16 is equal to 36. Combining like terms, we have a 9 to 16, 36. We will have x squared plus y squared plus 6x minus 8y plus 25 is equal to 36. Now I can subtract, to get this in general form, I have to have a 0 over here, so I can subtract 36 from both sides, and if I do, I will have x squared plus y squared plus 6x minus 8y minus 11 is equal to 0. And this right here is the standard form for this particular circle. So notice here that the standard form, or even the form that I have here, is not very intuitive at all. It doesn't tell you much about the circle at all. You can't figure out the center, you cannot figure out the radius. So there's not much you can glean from an equation of a circle in this form. Furthermore, if you have an equation of this form, you may not have a circle. For example, this graph can graph a circle, it can graph a point, or it can graph absolutely nothing at all. Well, how would you figure that out? Well, the way you would figure that out is essentially by taking your general equation and rewriting it in a center radius form if you can. But just for an example, notice here that this right here is a circle which is centered at x equals 1, y equals 2, and has a radius of 1. And this is the same equation in general form. This right here, this is an equation of a point. If this is equal to 0, then there's only one point that satisfies this equation. That's the point right there. And here is the equation in general form. So this does not represent a circle, it represents a point. And then finally, look at this one. Well, there is no value of x and y that if you subtract by 1 or 2 respectively and square them, you're going to get a negative number. And this can be written as this. Once again, it's the equation in general form, but this is not the equation of a circle. This is the equation that does not have a graph. So even though this is the general equation for a circle, you could have equations that look like this, and no, they don't graph a circle. They may graph a point or graph nothing at all. Okay, so the rest of this, the next thing we want to talk about is how to take a circle in general form and rearrange it into radius and center form if it is possible. And the way we do that is by recalling that the center radius form of a circle has x and y written as a perfect square. So to do this, what we need to do is we need to take our equation in general form for each variable and basically complete the square, i.e. add that number c that you need to add to make this expression a perfect square. Okay, in this particular case, c would be equal to 16, but it depends upon, but once again, it depends upon primarily this coefficient right here. Okay, so let's actually go ahead and see that in an example. Okay, so here we want to show that this is a circle and we want to find its center and its radius. So to do this, we're going to need to complete the square. Before we do that, let's rearrange this equation as follows. First, let's write this so that we have x squared plus y squared minus 6x plus 10y is equal to negative 18. We want to move the 18 to the other side. Now we want to group our variables together and leave some space. So I'm going to start off with the x terms. That's going to be x squared minus 6x, and I'm going to leave some space here, plus y squared plus 10y, and I'm going to leave some space again, and that is going to be equal to negative 18. Okay, now we want to complete the square. Now notice here, my linear term is negative 6. Now to complete the square, what I want to do is I want to take that negative 6, I want to divide it by 2, which will give me negative 3, and then I want to square it, which will give me, and square it, and we want to ignore the sign. And that will give me 3 squared. Well, if that's the case, then I want to add 3 squared here. But on this side, I want to add what that's equal to, which, by the way, would be 9. So I'm going to have plus 9. So we're adding 3 squared here. We're adding 3 squared here, although here we're doing it symbolically. Similarly, I want to take a look at my linear coefficient here. It's equal to 10. I want to divide that by 2. That's going to give me 5. And then I want to square it, 5 squared. So I'm going to add 5 squared here. But then I'm going to add plus 25 here, because that's what 5 squared is when you evaluate it. Okay, so notice here, now I have a perfect square. I have x squared minus 2ax plus a squared, and here I have y squared plus 2ay plus y squared. I can now write them in their perfect square form, and that would be x, parenthesis x, minus 3, the entire thing squared, plus, well, y, plus 5, the entire thing squared. And that is going to be equal to negative 18 plus 9, which will be negative 9 plus 25, and that will be equal to positive 16. So I'll have x minus 3 squared plus y plus 5, the entire thing squared, is going to be equal to 16. Okay, so what is the center? Well, the center is going to be the point 3, negative 5. What is the radius? It's going to be the square root of 16, or 4. And there you go. That's how you figure that out. Now, as I mentioned before, once again, by completing the square twice, we can transform the potential equation for a circle from the general form into the center radius form. However, there are 3 possibilities. First, if m is greater than 0, then we have a circle of radius square root of m, which is centered at hk. If m is equal to 0, we have a point. There's only one point that's a solution to that equation, and the point is hk. If m is less than 0, since we're restricting ourselves to the real line, the graph does not exist. Okay, so here we have an equation in general form, and we want to see if the graph here is a circle, a point, or non-existent. So let's go ahead and figure that out. To figure that out, we need to write this in radius form, center radius form, and that means completing the square. So notice here we have x squared plus 10x. Give myself a little space, plus y squared minus 4y. And I'm going to bring the 33 to the other side, so that's all going to be equal to negative 33. Okay, now let's complete the square here. X squared plus, here we have 10x. 10 divided by 2 is 5. Squared is 5 squared. So I'm going to add 5 squared here, and I'm going to add 25 here. Now over here I have negative 4 for a linear term. I don't care about the sign. 4 divided by 2 is 2. Squared is 2 squared. So I'm going to add 2 squared here. I'm going to add 2 squared here, or 4. Okay, put parentheses around here. Now this is a perfect square. This right here is going to be x plus 5 squared. This is also a perfect square. That is going to be y minus 2, the entire thing squared. And then that is going to be equal to negative 33 plus 25, which is negative 8, plus 4, which is negative 4. So the graph is non-existent. Okay, and this right here is the last problem that we are going to look at. Notice here that we are talking about the coordinates of the endpoints of a diameter. Now, if we know what the endpoints of a diameter are, then we can actually figure out the equation for the circle defined by that diameter. How would we do that? Well, the first thing we would do is we would find the midpoint of the diameter. That will be the center of the circle. So let's go ahead and do that. Here we have, and once we've done that, we could use that midpoint to find the radius, which will be the distance from the center to either endpoint on the diameter. And then once we've done that, we can actually write this thing in center radius form. Okay, so let's go ahead and do that here. And here we are given a diameter where the endpoints are 7, 4, and negative 9, 6. So the first we need to do is figure out the midpoint of that diameter, because that will be the center of the circle. So the midpoint, I'm going to call it m, is going to be the average of the x coordinates, because that's the midpoint formula. So that will be 7 minus 9 divided by 2. That's the x coordinate, and the y coordinate is the average of the endpoints for the y coordinate. That will be 4 plus 6 over 2. That will be negative 2 over 2, comma, 10 over 2. And that point will be negative 1, comma, 5. So that's our midpoint. Now we need to figure out what the radius is. Well, the radius is going to be the distance from the center. Once again, this is the center. It's going to be the distance from the center to any of the other 2 points. So how about if we pick this point right here? Okay, it'll be from the center to the point defined by negative 9, 6. So what will that be? Well, that distance is going to be equal to the square root of the square in the difference of the x values. So we are going to have negative 9 minus 1. That will be negative 9 plus 1 squared plus 6 minus 5. Well, negative 9 plus 1 is negative 8. Squared is 64. 6 minus 5 is 1. Squared is, well, 1. So we are going to have the square root of 64 plus 1, which will be equal to the square root of 65. This is our radius. So we have our center point, it's negative 1, 5. We have our radius, it is the square root of 65. We can now write the equation for the circle in center radius form. And that is going to be x minus negative 1, or x plus 1, squared, plus y minus 5 squared, and that's going to be equal to the radius squared, which in this case will be 65. And that will be our answer. Now the last thing that we want to go through is this particular problem here. Here we are given a graph of a circle, just like what you're going to see in your homework. And we need to write down the equation in circle radius form. Well, notice that this circle has a center. That center happens to be at the point negative 4, 4. So the center is the point negative 4, comma 4. Okay? Now also notice that the radius is 1, 2. So the radius is equal to 2. So what is the circle in center radius form? It is going to be x minus negative 4, which is x plus 4, the entire thing squared, plus y minus 4 squared, and that's going to be equal to 2 squared, which by the way is 4. There it is in central radius form. How do we write this in general form? Well, we go ahead and expand both of these terms, and that will give us x squared plus 8x plus 16, 4 squared, plus, and now on this side, y squared minus 8y plus 16 is equal to 4. Okay, we can arrange groups and combine like terms, and that will give me x squared plus y squared plus 8x minus 8y, and actually this should be 4, not 32. Now combining these, we will have plus 32 is equal to 4. And then finally we can subtract 32 from both sides, and we will have our desired result, which is x squared plus y squared plus 8x minus 8y is equal to negative 28. Actually, that is not our final result, because remember we actually have 0 over here. So we need to add 28 to both sides. I kind of did that backwards, shame on me. And that will give us x squared plus y squared plus 8x minus 8y plus 28 is equal to 0. And this is general form. And that is all that I have for this particular section. If you have any questions, please feel free to contact me. This is Bob Boyle, signing off.